So in the last session, we have completed about how can we like how the COP the EV owners, okay, or the EV charging infrastructure owners, how they will be communicating with Discom in order to set up the proper charging infrastructure. Okay. Now we will go for how the grid should be planned, like how Discom is going to plan the grid, okay, so that it can cater different demands. Readiness of the electricity grid to cater to EV charging demands is critical to achieve rapid and large-scale transition to EVs. Application of smart charging measures can help manage EV charging loads to certain degree without the need for grid upgrades. However, going forward, DISCOM planning process for grid upgrades and network expansion will need to account for EV charging loads. So generally, subsystems we all know. Okay, these are the images of a grid. Okay, substations and power stations. So you can say these these signs represents a charging infrastructure. Okay, offices, private chargings, home household charging infrastructures. Okay, factories are also there. So you can say that to begin with, DISCOM should conduct assessment of EV charging at the grid and feeder level. Okay, that means at both the ends, DISCOM should do the scanning. Like yes, how much the feeder is how much the feeder is like how much load the feeder can have, okay, and how much the grid can supply to the feeder, because the grid is always working. Okay, the grid is completely, it is always working. Okay, and every time new factories come, new type of load balancing is required. Okay, so the grid has to send some loads to another, you can say, reason for balancing. So to get proper, you can say, supply to the feeder level, and also without overwhelming the grids. Okay, DISCOM should plan this. Okay, DISCOM should plan this so that we can have what the COP. Okay, CPOs can have proper setups of infrastructure. Differential EV charging patterns and the modeled impact of TOD, time of day measures. This will help DISCOM devise their load management strategies, developing grid upgrading plans, and plan for increases in power purchase agreements. So power purchase agreements is not done on the feeder side. Grids also purchase power from another grids, okay, for their supply. Grids also purchase power from another grids. DISCOM should develop EV readiness plan based on charging load impacts on the grid infrastructure. National and state regulators are advised to direct the DISCOM to undertake impact assessment and prepare EV readiness. So you can say the box I. Okay, here this is the box I, the impact of EV charging on power demand. Okay. So here we will see that how the time of day affects the supply at different day also. Okay, this is of Delhi in summer season. Like in the you can say morning time, night time. Mostly we see that at 1 or 2 o'clock the peak is there. Okay, up to 3 o'clock the peak is there. Okay. So the peak is there. Then you can say 1 to 24. Like 1 means obviously we represent this is the night time. Okay, 1 a.m. 24 is the 12 a.m. Okay. So different discom sites, discom one site of Delhi. Okay, in Delhi you can have 2 or 3 different distribution centers. Okay, so discom one, discom two, discom three, discom four, different charging loads. So by using these metrics, discom can effectively select, like the feeder point should get how much amount of available power, and the grid, and how the grid is going to integrate that power requirement to its uses. Okay. Then comes models of EV charging implementation. Okay, so different models, like how these models are the baselines. Okay, remember these models are the baselines of implementations. Okay, like a model is very easy to implement because a model has all the required contents and all the required report generation and everything. Okay, when we say a implementation model, that means it is a ready to apply model for getting the things done. Okay. So typical roles in charging infrastructure implementation. A typical charging infrastructure implementation model involves multiple roles, which may be taken up by one stakeholder or delivered through partnership between different stakeholders. Apart from the setup, Apart from the setup charging infrastructure, other roles include land provision, electricity supply, EVSC supply, charging software solutions, and customer services. Okay, so a model includes all this. A model of charging infrastructure, okay, not only includes the stakeholder, okay, like who is the private party who is going to buy, or which government is helping the private stakeholders to set up EVAC, okay, sorry, EV charging infrastructure. Along with that, the land provision, electricity supply, EVAC supply, charging software solutions, and customer services, all these things need to be done. Okay. First is procurement of charging infrastructure. These are the components of model. The stakeholder procuring the charging infrastructure is the driving partner for implementation. Okay. Procurement can be undertaken by the primary use of charging infrastructure by the charging service provider or by the governing authority responsible for providing charging infrastructure. See, the charging infrastructure, like if Tata is tying up with a private player, okay, then in the Tata, remember, a private player means nearly 60% or 70% investment will be done by Tata and 30% will be done by the private owner. And mostly it is seen that if a private owner has land, okay, the land price is the percentage of the percentage he will be getting. Okay, the land price. So if mostly companies, governments want that either you should have a given amount of money. That means, let's say the infrastructure cost is nearly 80 lakhs to 1.5 crores. Okay, for a small station. Okay, with two, three EV chargers and like full four wheelers, two to three full two wheelers. All these chargers are included. Okay, so when these are included, it will surely cost around 80 lakhs to 1.5 crores. Okay. And if or let's say 80 lakhs to 100 crores. Okay. Sorry, 80 lakhs to 1 crore. Okay. Now, government or any tying up agency will give you 50-60% of their cost. Okay. The rest 40 lakhs will be arranged by the private owner, either through land or through cash. Land provision, the space required for EV charging may be owned by the procuring stakeholder or may be acquired on lease or alternative arrangements. Like if the stakeholder has land, he can use his land for getting the percentage of the shares or of the profits. Okay, it will be distributed like that. Or he may have cash. Using that cash, he may lease lands. Okay, or using that cash, he may buy also the components. Okay, mostly the component buying is not given to the stakeholders. Okay, because that's a degradation thing. If something degrades and they are responsible for that, obviously the whole infrastructure is weakened. So anything that is consumable and degradable, mostly the bigger party owns that. Okay. And the smaller party tries to own something that is fixed, like the land, assets, okay, like buildings, okay. Other assets, those are mostly fixed. Those that will be owned by the, you can say, stakeholder. Okay. The bigger player will hold mostly the, you can say, any consumables like this electronic equipments, the power supply grids, okay, the power supply path, all these things they will be holding. Okay. Okay. Then comes the energy supply. Energy supply for all EV chargings. Energy supply for all EV charging installation is provided by the DISCOM responsible for power distribution in the region where the charging facility is located. Okay. Then energy supply. Okay, energy supply will be provided by the DISCOM, and DISCOM will tie up with the bigger part like Tata or any government agency. Okay, or directly DISCOM can be a partner. Then EV supply equipments. EV chargers may be supplied by EVSC manufacturer or retailer. For semi-public or public charging, CPO are usually responsible for selection and installation of the required arrangement of chargers. Okay. They're responsible for selection and installation. Sometimes in CPOs, like if the CPO is fully, you can say, or the CPO stake is nearly 80%, and the government stake or the bigger player stakes, okay, is like Tata, Mahindra, okay, their stakes is less. Then the CPO generally has to own the supply equipment. So charging software solutions, system management software is used by CPO to manage their network of charging points. Okay. Responsible for selection and installation of the required arrangement of charges, charging software solutions. System management software is used by CPU to make their network charging point to track the control charging session, run diagnostics on the charger equipment, and for other backend services to manage customer subscription pricing structures, etc. Charging solutions may be offered as a white label solutions from third-party vendors or may be developed in-house by CPU. Okay, in addition to implementation stakeholders, CPU and ESP are responsible for customer service at CPU. So, charging software procurement. Okay, this is the model. Okay, that has to be taken care of by the CPO and the installing authority. Then models of implementation. Okay. There are three broad implementation models for charging infrastructure categorized by stakeholder group responsible for charging infrastructure procurement. The government-driven model, the consumer-driven model, and the service provider-driven model. Okay. The three models. So first is government dividend model. In many cities, public charging infrastructure provision is led by government agencies. So we have seen this. Most of the government and semi-government agencies tied up with Tata and other companies responsible for public charging infrastructure. Okay. They being tied up, they are or the state nodal agencies are responsible for public charging infrastructure. Public land aggregated from different government and public sector bodies is provided for the installation of charging facility. Okay. So government-owned lands will be used for providing the charging facility. The charging equipment may be owned by government or by a CPO that is contracted to own and operate the charging services. Like if a CPO wants to be a part of the government-driven model, okay, the charging equipments, you can say, may also be owned by the CPO. For self-owned EV charging facilities, public sectors agencies procure the EVSC equipment through a EPC contractor with a partner. Charging services may be self-managed or outsourced to a CPO. Alternatively, government authorities may enter a PPP contract. We'll see what is this PPP contract with a partner. Here, the relevant government agencies invite CPU to install and operate EV charging facilities for public use. In this model, government offers financial subsidies and concessional land provision. Okay. Like if through government sanctioned, you can say implementation, if the CPO is also like, if the CPO is ready to give some cash, okay, or it is the CPU is ready to share some cash with the government for the installation of the public charging infrastructure. Then government can also aid in financial subsidies, like while buying those EV supply equipments, the CPO may get subsidies. Okay. For land, it may get some provision like for some lease, okay, in order to install the infrastructure. The government driven model is an example of which is described in the box J. ensure the adequate availability of public charging. This model is likely to be more dominant in the early years of EV ecosystem developed to set up a basic network of public charging facilities. So this is a small example of Delhi's EV charging infrastructure. Like Delhi Transco Limited (DTL) as the state nodal agency for charging infrastructure setup has invited bids from privileged agencies to set up and operate public charging stations. So first a bid will open. Like these three areas are there. Okay, this much price will be invested for setting up, and this much has to be provided by the stakeholders or by the you can say bidders. Okay, everything like the bid for the charging stations, the land, everything the bid will happen. Okay, the tender will be awarded to the companies charging the lowest service fees. The concessionaire is responsible for supplying erection, testing, commissioning, maintaining, and operations of PCs at its own cost for design lease period. The concessionaire CPO will receive the cost via service fees. Then land for charging station is provided by the government with land parcel aggregated from various public agencies. Land is provided on revenue sharing basis. Okay, and concessionaires will pay a fixed rate of 70 per kilowatt of power to sold on site owning agencies for a duration of contract period, generally 60 months. Okay, 5 years. The discom the discoms are mandated to provide electricity connection up to 100 kilowatt sanctioned load for public charging facilities. Okay. That means discom can easily provide 100 kilowatt. Okay. In the last session, we have seen that if we generally charge two EVs, okay, with fast charging is 30 kilowatt. So 30, 60 kilowatt. Okay. Two wheelers. Okay. 14 kilowatt. Okay, and certain other three wheelers. So 10. So by mixing all this, generally we get 100 kilowatt. So 100 kilowatt is the minimum sanction. Like Discom can, sanction a minimum of 100 kilowatt. Regulatory support for application permission, quality check, site feasibility approval, etc. is provided to the concessionaires by the SNA or any other body mandate the contract. The SNA will also support the concessionaires in taking up early release of the electricity connection with respective discount. At the end of the lease period, the concessionary may choose up to take up ownership of the charging infrastructure asset by clearance the land owning agency and discount. This is a special type of public partnership. You can say this PPP. PPP is public-private partnership for EV charging infrastructure. So this is the model of Delhi, and other states are also following the same model. Consumer-driven model. The consumer-driven model is employed for private and semi-public charging facilities. Okay. Consumer-driven means consumer who has an electric vehicle and want to set up a charging infrastructure for him and also for others. Like I have an electric vehicle and I want to set up infrastructure for me charging and also for others. Primary procuring stakeholders include private entities such as malls, commercials or institutional establishments, retail shops, restaurants, etc. that have parking available on their premises to host EV charging facilities. Okay. So these are consumer driven. They will most commonly partner with a CPO to take care of EVSE supply, okay, and installation and maintenance as well as the management of service operation. Okay. Now, consumer driven means here there will be no government authority. Then there will be a CPO, okay, and there will be a mall or an institution. There will be a tie-up between the CPO and the mall or the institution to set up the charging infrastructure. While EVSC procurement by the private entities typically through direct purchase, new models around leasing of EVSC equipment from suppliers CPO are also in. Other consumers using this model include private EV owners and fleet operators. Okay. Like not only the malls, okay, you can say private owners, like anyone who is owning 2 or 3 electric vehicles. Okay, he's a private owner. Okay, he has 3 electric vehicles for his own personal use. Okay, for his own personal use, or is a fleet operator, like he has 3, 4 EVs, but being used as a fleet. They can also install through this tie-up. Okay, like they will go for a CPU. They need a CPU. Okay. The implementation model is straightforward for EV owners who may procure the EV charger from their automobile OEM, okay, and EVS retailer, a CPU or a discom, depending on the type of charger and power connection. Software services may be available to the EV owner through a mobile application to control charging sessions, take advantage of TOD tariffs. So, like if you are a EV owner, you are installing a charging setup, okay, for fast charging, not portable. So portable ones are not, they don't belong to TOD. Okay. Though you can have some low end or low wattage chargers, but mostly the TOD tariffs like can be utilized for a profit if you go for nearly, if you go for, you can say, a bigger or a charging uh, station, or you can say with fast chargers up to 30 kilowatt. Okay. If you have fast chargers up to 30 kilowatt, it will be very good for you. Okay. Like you can fully use the TOD and you can say TOU. Okay. TOD is the time of day and TOU is the time of use. You can use both of them. Okay. TOD and TOU for your profits. Like the one who is charging will be using your charging supply. Okay. But he will be paying you as a as he is going for fast charging, okay, through your supply. From that, individual EV owners and fleet owners can also expand their, like if they are owning, because setting up a charging infrastructure is like it is costly. Okay. So owners can very easily manage this to properly, you can say, set, like invest the price in these things. Okay. Then this is the SEBI public charging station. Like accessing to charging infrastructure in residential, township, and office campus is essential to enabling higher rates of EV adoption. Yes, like wherever we can have some vehicles charging, like if we try to install, like we try to install the charging stations in these areas, EV adoption will grow. Okay, EV adoption will grow a lot if we are able to use this. So what this will do, since we are able to use institutions and everything throughout the traffic or throughout the road, we can have them installed. Okay, anywhere a small government office is there, we can install a charger. Okay, so this will keep in control the range anxiety for EV owners driving for a longer distance. To cater to this growing demand, private CPOs are providing plug-and-play solutions for semi-public charging facilities for both existing and new developments. On CPO has developed two wall-mounted chargers, 3.3 kilowatt AC and 7.5 kilowatt AC for use in residential communities. As a part of servicing offer, the CPO providers end-to-end hardware, office installations, operation and maintenance support. The charger comes integrated with wireless monitoring and data logging, which is enabled via the CPU, online and mobile platforms. Okay. Okay. The user software integrates the existing facility management software of the residential societies, streaming authentication and billing process for the residents. There is no dedicated manpower required. Okay. Once the charging station is installed, a QR scanner will be generated for that same charging station, and by scanning the QR, anyone can charge it. These are the basic models that are implemented by different like this is how the government and the private owners are trying to adopt the EV charging, okay, or mostly go into the EV charging infrastructure, because the EV charging infrastructure will become $1 trillion market, okay, way before 2030 in India only, okay, because you can see the rising fuel cost. Now, once the fuel cost has rose, you can say it will again dip to a very high price, okay, or it will again come back to a very high price, okay. Okay. As building bylaws come to effect and EV charging facilities become essential amenities, this model is expected to scale up significantly. Okay. This model is expected to scale up significantly. As I said, that this will reach most of the like government, consumer-based model, and finally the service provider model. Okay. These three models, so, can say will help this setting up this big $1 trillion, okay, multi-trillion-dollar industry. In the service provider model, it is that the CPO that drives EV charging provision for public and semi-public charging. The key distinguished features of the service provider are the EVSC equipment is usually owned by the CPO. Okay. Land is sourced from variety of owners, including public and private entities. Charging services are offered under the brand of the CPU. Okay, just see here. Here, service provider model. Okay, there are distinguished features. Okay, semi-public charging, public and semi-public charging, where the EVSC is usually owned by the CPU. There is one owning authority CPU. There is one another owning authority, that is land. Okay, then brand of the CPU will be used. Private CPU aim to establish a network of charging facilities in strategic locations with high potential charging demand. They source land parcels in selected locations from public or private entities, install EVSC equipment supplied by manufacturing partners, and operate paid EV charging services for public or semi-public uses. Okay, it is just like you see that like the franchisee model of service stations. Okay, your Tata Nexon service station or Tata service station, like someone is owning a service station, so he has the already has the land to charge it. Okay, so they can install. Okay, already owned service providers can install it. So that is a service provider model. Okay, that is they already provide the service. Okay, that means they are owning a service station, they are owning a pump station, a gas station, or they are owning something like that. Okay, and there they install it. Discom are also entering the charging infrastructure market as CPOs. Okay, Discom is not a direct partner. Okay, but now it is entering as a direct partner. As seen in the box L, these agencies typically use their own land to set up, like government land they use whenever possible, okay, for setting up the charging infrastructures. Okay. Then Discom may also provide bundled charging services for private EV owners and recover the capital and operating cost through electricity tariffs. Other stakeholders driving the service provider model of EV charging implementation include industrial companies that are moving into charging infrastructure and EV manufacturers that are setting up charging infrastructure network as allied services. So this is the box L model. Okay. A mix of public and private CPU is currently leading the development of public charging infrastructure, that is your EESL, Energy Efficiency Services Limited, a public sector undertaking, and had more than 200 charging stations operational by January 2021. Private sector discoms such as BSES, okay, Rajdhani and Tata Power are also have been active in public charging infrastructure provider. Okay, Tata Power EV charging network comprises over nearly 500 chargers in 100 cities. BSC Rajdhani is in July 2021 floated a tender to empanel charging infrastructure provider to deploy normal power AC and DC chargers for semi-public and private users in Delhi. This is the first of its kind tender that will clarify CPU and provide a single window facility for streamlined installation of EV charging. Private CPOs with notable network of public charger include Photom, Magenta Charger Zone, Voltic, Static, Chargers, okay, Charger, and among other. Okay, so these are some of the companies, CPOs. Okay. Generally, they set up charging infrastructures. specialized in different public charging uses ranging from 50 to 60 kilowatt DC fast charging stations to compact 3.3 kilowatt. AC charging point, AC charging points and street light charging solutions, battery charging and swapping providers include Sun Mobility and lithium power. Okay. Ether Energy can an EV manufacturer has its own network of DC chargers for electric two-wheelers. Okay. Public and private CPU are working with multiple partners, including oil and gas companies and EV manufacturers, to deploy and scale up the public EV charger. Because only when there will be a scale up, okay, of this charging infrastructure, then only we will be able to see the, can say, correct. Like we will see the reduction in this charge anxiety. Okay. So now since we have seen the service provider models, okay, we will see some like other models that are implemented in different other regions. This is a report, another report, okay, that generally shows like type of chargers needed for two-wheelers, three-wheeler goods and car personnel, okay, and commercial four-wheelers, trucks and buses. Because buses are also your city buses, they are all electric, okay, they have to be charged, okay, and the models. Public charging infrastructure, that is the government-owned models, semi-public charging infrastructure, and private charging infrastructure. Ownership, municipal authorities, PSU, CPO host, properties, travel mode, all vehicle except passenger vehicles. Okay. So remember, in municipal authorities, PSU and CPU, all models are there except passenger vehicles, public parking lots, charging plazas, petrol pumps, highway metro stations. Okay. Standalone public charging infrastructure. Or host properties, passenger public vehicles. Okay, these are for bus, big bus, because bus cannot fit inside a petrol pump for charging. Okay, so you need to have a private property for charging of bus. Passenger public vehicles, private passenger vehicles, commercial passenger vehicle goods carriers. Okay. Apartment complexes, office campus, gated communities, shopping malls, hospitals, universities, etc. Now we will see here, okay, different types of norms or types of authorities that comes into account. To ensure safe and compatible and interoperable EV charging infrastructure, it is important to understand the norms and bylaws set by various authorities. They are formulated and enforced by the concerned authority of EV charging. Policy making, regulatory authority. Okay, actually we have seen this. Okay, we have seen this in the last session. Okay, so I will not go through. Okay. Then we will jump to our demand assessment. Okay. The demand of a vehicle, the EV charging infrastructure depends on penetration and utilization of EVs. Accessing charging demands by EV vehicle types divided into segments of foundational steps. So segment EV by vehicle type, there is two-wheelers, three-wheelers by characteristics. Like how you are going to segment. Okay, this segmentation is very much important to set your TOD and TOU charges. TOD means your time of use and time of day charges for both active and passive charge. So determining EV characteristics for each segment, operational traits like energy, efficiency, range, charging frequency, and public charging shares are documented. For instance, public cars rely on public chargers for 10% of their charging need, while trucks and medium good vehicles depends on 70% for them. Okay. It is a very important metrics, like which charger is relied how much so that the maintenance of that, power supply of that can be kept in a certain quality. Okay. And for that, certain charges will also be demanded. Deriving charger, you can say charger characteristics, the analysis include charging speed, efficiency, operational time. Okay, charging speed, efficiency, operational time, idle time to estimate the number of vehicles a single charger can serve daily. Okay. See, these will be used by whom? By CPO for perfect or correct maintenance and correct calculation or correct financial calculations. Charging time and total vehicle charge are calculated using a specific equation that factors the battery capacity, state of charge, and charger speed. Forecasting EV growth using estimated of EV cells, penetration rates, and future targets. The number of EVs in each segment is projected for a given horizon. Calculating required charging points. Okay. So now how you are going to calculate how much charging points are required? Combining forecast, this EV growing forecast with the capacity of a single charger, the total number of charging points required for each vehicle segment is determined. Okay. Remember, by these things, determining EV characteristics, segmentation, deriving charger characteristics, forecasting EV growth, by including all this, the capacity of a single charger, sorry, the charging points required for each vehicle segment is determined. This ensures the infrastructure alignment with EV. Once these are computed, the results includes segment specific charging point estimated and visualized in the graph for practical applications. Okay. So you can say these are now who will be using this? These are the models to be used by the CPUs. Okay. For properly load for proper load balancing. Okay. And for proper, you can say, like if the charging requirement is of 100 kilowatt, but the CPU has set that the charging requirement will be 500 kilowatt. So daily that discom, what it does, it preserves some power to send to the CPU. But it's going useless. Discom might have sold that much because the energy is continuously generated. Okay. Energy is continuously generated. So when we are preserving means actually we are not losing. Okay. But we are also not gaining anything. Like the discom is not able to sell anyone that energy because it is reserved. Okay. So what happens in that reserve? Obviously loss because discom might have sold that to someone else, but he's not able to sell it. Okay. Certain models has to be followed. Okay. For proper setting up these infrastructures. Okay. Guys, just give me 2 minutes. Okay. So these are the models that has to be used for dynamic load balancing. And for load balancing means from DISCOM to the CPO end, how the load balancing has to be done. So for that, average utilization or distance driven per day in kilometer, average battery capacity, average maximum charging speed supported, state of charge used. Okay, all these things has to be taken care of. Now, another way, remember, these are all the terms for your load balancing. Okay. This demand assessment, because when we are able to predict certain thing, then we are able to balance it also. Like I will be falling. Prediction, balancing is the outcome. Okay. So demand assessment is a type of prediction that will be used for your balance assessment. Demand assessment using geographical parameters and fleet estimation. Charging infrastructure numbers uses geographical parameters can be estimated using a two-step process. Step 1, estimating the minimum charging station required based on the size of the city. Estimate the total number of charging points required in the city region based on number of vehicles at the charging point. So how the calculation will be done? Minimum charging station, determine the minimum number of stations based on the city region as per MOP guidelines 2024. At least one charging station is required for every grid of 1 kilometer by 1 kilometer. Okay. That means for every 1 kilometer by 1 kilometer grid, one charging station should at least be there. Okay. For properly maintaining this charging infrastructure. So city size 1 square kilometer, minimum number of charging station required is 1. Okay. Total charging point, calculate the required charging point based on the EV fleet size, vehicle types, charging capacity, steps to estimate charging points. Okay. First is project EV fleet size for different travel modes based on sales penetration rate and future projects. Okay. So for each city, calculate the total, like this should be done by the government. Like it should get the data on how much EVs are sold. The so I can say sellers or retailers should give this information to government. Penetration rate, how much the EV retailers are trying to penetrate or how much sales they are demanding and or how much sales they are going for and the future projections. Calculate the number of charging point needed for each mode based on fleet size and capacity. Okay. Then location identification. Okay. We'll go for directly for balancing. Okay. Then we will go for the model that again has to be followed by the CPU for proper load balancing and for proper management of the charging infrastructure. So first is access to defined users. Okay, define control system for access, define payment systems, define type of vehicles, number of space, length of stay. Okay, define load capacity for charging stations and type of charger, power connection type, site selection, layout of charging station, bylaws and standards, government approvals and permissions, cost considerations, implementation and day-to-day operation and maintenance.